All right, I'm going to talk today about something that's going to seem a little random, but it's going to get to Bitcoin. And that is your passport, if you have one. And this is in any country, there is a technology they use in passports, and it is chip technology. So, silicon, maybe some copper, some plastic is in this little chip, and there's data on that chip. And that data is your data, things like your name, the passport expiration date, your birthday, a few other things. It does not contain your social security number, even though you usually have to give that to the government in order to get a passport. But the data points that are on the chip that's not one of them. But still some personal things. But anyway, then there is also, so there's the data, and then there is, it's called an SOD. I don't know what that stands for. I read it, can't remember. But anyway, that has hashes of these data elements, and it has the signature where the government used its own private public key pair. It used its own private key to sign your hashes. So there's not, you don't have a unique public-private key pair as an individual. The government has one private key, and they use it to sign everybody's data. So when you sign data, and I've done another video on this, you're going to get a unique signature that can be proven. And that's what the border agents are doing when they're reading that chip. They're making sure that your government verified that the data that is on your passport is valid, and that nobody slipped in different data or a different chip or whatever. So that uses ECDSA. So that might sound familiar to some people who've been watching my channel, because I've done a couple videos where I talk about that. And ECDSA, it stands for Elliptic Curve Digital Signature Algorithm. It's part of ECC, elliptic curve cryptography, and it's a signing algorithm. And so the government uses the same thing that Bitcoin does. Now, they happen to use a different curve type. So in Bitcoin, they use SECP 256K1. And you can study about that. It's really cool to learn about that, but I won't go into that. But that's the type of curve that is used in Bitcoin. Whereas when the government signs your passport, they use a different curve, but they use ECDSA. It's just a different type of curve. So you're going to have a different framework or boundary for the random number that is the private key. So what else do I want to talk about with this? So ECDSA, the signature in Bitcoin, is super important, just like it is for your passport. Why is it important in Bitcoin? Well, first, let's talk about, and I don't usually talk about the other chain called BTC Core, because I don't really like getting into, arguments with people. It's just not my style. Other people like to do that. They like to go have fights on X. But anyway, SegWit destroyed the real original Bitcoin, its implementation. I can't remember what year it was. I'm not a Bitcoin historian. It's probably 2017. I think it was 2017. But anyway, they took the signature out of the transaction data and stuffed it in another spot that could theoretically be pruned by miners. So you just sort of have to trust that it's in there and that you can track it. So the signature is super important, and I'm going to tell you a bunch of reasons why. And all of these items, and this is where I might get argument from core people, but all of these items are broken by SegWit. So the original Bitcoin signature purposes is what I'm going to talk about here. So ownership. You sign that. So you have ownership of what it is that you, or rather, when you sign a transaction, you're moving ownership to someone else. So it's the chain of digital signatures. Identity. Who are you? The signature allows us to do that. Hang on, I have a raccoon outside my window. Still out there? Go away. Because they eat the kitty's food. See, they eat the kitty's food, and now they've just eaten everything. Hang on. All right, so I'm back. So identity, integrity. Integrity means wholeness. When you take something out of the original protocol and you stuff it somewhere else, you take a very important part out. So the transaction data and the block, none of it has integrity anymore with SegWit. So auditability, you can't audit something if you don't have the most important part, which is the signature. Traceability. Say somebody did something illegal on Bitcoin. We want to be able to trace that. So there's a lot of people that think that you shouldn't be able to trace things, and so with pseudonymity and the proper use of never using the same key, you're going to be pretty anonymous on Bitcoin for digital cash transactions. However, I say pretty anonymous. That's why we use the word pseudonymous, because if something illegal happened, we need a way with a court order to be able to go look at what was illegal. And so traceability is important. BSV is a chain that operates within legal confines. I believe it's the only chain that does. So the signature is super important in all that. Accountability. You're accountable for where you send your coin, why you send your coin, how you send your coin. You're accountable by your signature. So if I was sending coin to Susie and she said I never got it, I would be able to show her that I signed the coin over to her with my signature. Immutability. So with immutability, the signature is part of the transaction's identity. So it can't be changed. It's immutable. If you strip it out, like they do in SegWit transactions, it's no longer immutable. The TXID does not reflect what actually happened. So, and then just a point of information on the TXID. So the TXID is a hash of the transaction data. In SegWit transactions, the TXID does not include the signature. And so then if you think that all the way through to the integrity of the block with the Merkle root, because the Merkle root contains all of the transactions in the block, but that Merkle root no longer has the integrity of a signature. So, another reason why it is really bad. And then the last thing is non-repudiation. Non-repudiation. So what that means is that I cannot take back the fact that I signed something. If you don't have the signature data on a transaction, there's a lot of things that can happen. So for example, the miners can prune. They can prune that witness data. There's no requirement that they keep that witness data. Now they say they do, but you kind of just have to trust them. And it's also messy. Like, for example, there's script types that are more complex that you can't do without the signature. It's very not good. One thing that I do want to say is that on BTC Core, you can still do a P2PKH transaction, meaning a non-SegWit transaction. And those transactions do still happen. They're not very often. They're discouraged. All of the wallet providers were told to push SegWit. And the reason that they push it, I mean, they have their whole reasons. There's a narrative about malleability. I'm not going to go into all that here, but that's what they say. They say it's that transaction malleability was dangerous, and it's a whole other thing. It's not dangerous. It was actually by design. But they push it because their layer 2 technologies require SegWit in order to work. So you've probably heard of Lightning technologies, and then Liquid is a side chain. There are probably other things that they're doing out there. I don't really look at that chain too much, but I know that Lightning and Liquid both require SegWit in order to work. So they pushed it for their layer 2 technologies to work. Anyway, we don't really care about that. We don't care that BTC Core is broken and the narrative was hijacked, etc., because we have BSV now. And we have Teranode, and as you've probably heard, Teranode is now doing, or rather, at least can do, 1 million, and I've heard up to 2 million transactions per second. Now, we don't have that transaction volume on chain right now, but there are many people that are now starting to build to make that happen. Now, people have been building on BSV since it began, and there's a lot of pioneers, and they've done great things, and they're still around, a lot of them. But people have complained that, well, why do we need Teranode since there's so few transactions anyway? Well, in some ways you could say if you build it, they will come. But it's not just esoteric, it's actual. Because if you think about it, if real business people think through, well, why would I use a chain that has vulnerabilities from layer 2s, smart contract vulnerabilities, etc., if it won't scale for my needs? So when the word is out that we now have a layer 1, very secure, the most secure blockchain there is, that can scale to millions of transactions per second on layer 1, people are going to start to build. I know I'm building. I'm building an application that I hope will contribute to the volume coming on chain. And I know there's a lot of other people that are building too. So it's exciting times. Anyway, hope that my little digression about the passport using ECDSA was helpful. Understanding the parts to Bitcoin is really important. And that's what I am trying to do here, is to help you understand the parts so that you can understand the whole, so that we can have a better and more honest world.
Got a curve in the game, laid out clean, with the point named G and a math machine. Pick a secret number, that's your key. Multiply G, now the public can see. On the curve,